What's up? What's up? What's up? What am I? What am I?
Math Olympian.
One person? Guys, 2 seconds ago, you're like, be the Math Olympian, be it! And I'm like, what's up? What's up? And then you're like, I'm like, what am I? One person.
Keep keeping this on.
Yeah, dude. So give a hand to the 3 rookies of Yay Math. Let's clap for them. Welcome. We're making good for you, and you, and you, and thank you, veterans. All right, let's rock and roll this. So, question for you. Yay what?
Yay!
Nice, nice. On key. Okay, so we're going to talk about absolute value inequalities. I think this is moderate to challenging, and we're going to tackle that today. All right. So first, we have this idea of a compound inequality. What does compound mean? What do you think? Best guess. Your own words.
2 things together.
2 things together, right? Okay, so 2 things together. Let's say we were to do this first problem, 3x plus 1 less than 7, or 7 minus, oh, excuse me, 7 is less than 2x minus 9. All right, dude, I'm feeling this lesson, you guys. I'm feeling it. This is good. This is good. The energia is good. Okay. So treat this like 2 different statements and solve, right? I'll race you. But don't be careless. Minus 1, 3x less than 6, x less than 2, or plus 9, 16 less than 6. Who's done? Nice. Okay, I lost. I want to lose. Divide by 2, so then that's 8 is less than x. So preferably what I want to do, get us in the habit of doing, at least while we're learning, is to bring the variable to the left. So this would be x what?
Greater than.
X greater than 8, yes sir. And nans. Okay. And if we were to graph this on a number line, we would do it like so. Number line coming. Generally speaking, for purposes of number line, just graph the points of interest. So we have 0, we have 2, we have 8. On the 2, open or closed?
Open.
Open. Class, left or right? Anyone else?
Left.
Good job, you're doing great. Left, yeah. Am I going too fast?
No.
Okay. And then open to the
Right.
Okay. So these are the answers. This or this. That work for this system here, this compound inequality. Right? And this is the graph that represents it. Now what I want to talk to you about is this word or. Okay? Let me ask you a question, please. Cornelius, hello. That is your name. Okay, so Cornelius, suppose you went out on Saturday and not Sunday. And I asked you, did you go out on Saturday or Sunday? What would your answer be?
Saturday.
But would your answer be yes or no?
Oh, I hate those.
You went out on Saturday, and I asked you, did you go out on Saturday or Sunday? Would your answer be yes or no?
Yes.
Yes! Very good. Your answer would be yes.
No, that confuses people.
Oh,
Let's talk about it.
You're like, yes to which one?
Yes, the answer is correct. You're one step ahead of me. Yes, I went out on Saturday or Sunday. Because the word or implies how many of these need to be true?
1.
1. Or both. Both is okay too.
Oh.
Both is okay. Can any number be true for both of these? Can a number be less than 2?
Yeah.
And also greater than 8 at the same time?
Yeah.
No.
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 But it can
Think
be
about it,
one.
like a number like 0. 0 makes this one happy, but does not make this one happy. But 0 is acceptable. 0 is acceptable because 0 makes this happy.
So what's the answer?
The answer is this or this. That's the answer.
Oh.
Okay? At the beginning though, if this said and, imagine, pretend it said and. This is a good use of time because we're going to get into some hard problems. If this said and, suppose you went out on Saturday only, and I asked you, Cornelius, did you go out on Saturday and Sunday? Your answer would be?
No.
No, I did not go out on Saturday and Sunday. So if this said and here, what would the solution be?
No.
The x less than 2.
No solution.
Oh.
No solution. No
So
solution.
we don't even take one of them?
Because it can't.
Because there's no number that fits for this and
Because
this.
it can't be less than 2.
Oh.
Okay? Or is okay here, and is not okay. Alright? So if you have or, now I'm going to start to go like this. See, the graph goes like this, right? Right? So, I'm like an Egyptian here. If you have an or going like this is okay. But if you have an and going like this, what's the answer?
No.
No solution.
No solution. Very good. So I'm going to speed up the recording on the tape. Because it's funny. I've gotten positive feedback for that, actually, honestly.
For what?
For like,
Speeding up the recording.
Oh, when you
if they
erase
need to
it?
move fast or something?
No.
Yeah, like.
No, and that part that you
Why
just did.
do it, you know?
No, like edit out the part that he's writing stuff.
No, writing is cool, but oh, now we're gonna start this. It always goes, oh. Okay. Next problem on your paper. What we talked about with the, did you go out Saturday or Sunday, or Saturday and Sunday is gonna apply. Now, I am going to grab this better green here. Good. I'm circling this stuff inside, x plus 2, okay? X plus 2 can result in what types of numbers? What examples of numbers, perhaps? What do you think? Yes?
Positive and negative numbers, right?
Okay, sure, let's start with positive, right?
Um,
So, can x plus 2 result in the number 2, for example? If the stuff inside here became the absolute value of 2, would the absolute value of 2 be greater than 3? No.
No.
So instead of 2, perhaps what's another example of what this green circle can result in? Yes? 4. What else? 5,
6, 7, 8.
So large things. Anything what?
Above.
Anything above 3. You're right. Anything above 3. So I'm going to write x plus 2 can result in numbers greater than 3. Because if x plus 2, notice, x plus 2 is exactly the stuff we circled, resulted in numbers greater than 3, we'd be happy. Okay? Now, Ecclesiastes in the back, you said, yeah,
Are these mathematicians?
yeah, all of you are mathematicians. Wah. That's how I do magic at home. Anyway,
What?
now, how would, it's outside. You'd mentioned negative numbers, correct? So let's follow through with that. Can this result in some negative numbers? Because we're going to take the absolute value of it, won't we?
Oh yeah.
Right.
Right.
So now as a class, can you guys think of numbers, negative numbers, that this green circle can result in?
-4.
It can result in -4. I'm going to put -4 here.
-3.
Can it result in -3? Did you say that? That's a very good guess. If this resulted in -3, notice it's not or equal to. So I'm going to get back to it.
Oh,
Right?
okay, so
Right. Not -2 either.
Has to be greater than 3.
Let's ask. If the x plus 2
Oh,
results in -4,
I thought that
Right.
negative, was from x.
not for x to the very, very, very good.
Yeah.
I'm trying to get away from x
Oh.
because
-5.
what's in here, yes, good, -5. Good, good.
-6.
What's in here will change for every problem. I seriously have goosebumps because we're having those aha moments. Love those! No one's in here, it's okay, we can scream. Scream right now. It's like a cacophony. Okay. What's in here can vary. So we're talking not about x, but what this results in, this circle. And now let's talk about why this circle can result in -4. Because if it results in -4, absolute value of -4 is
4.
4. And is 4
Greater than 3.
greater than 3? Yes. It's okay, it's doing it. It's doing its thing. Don't sweat. So -4 is fine. What about -5
5.
is fine. I'm going to put -5 in here. Just like Ecclesiastes said in the back, if this results in -5...
Oh, that's me.
Yes, explain. Long. See, I just made a new name for you. If this results in -5, explain why -5 is okay for this result. Because the
Because the absolute
value of
-5
is
5
and 5 is
greater than 3.
very good. Good job. So now we're on it. Numbers like -4, -5, -6, -7. What relationship do these have with this?
They're larger than 3.
That's a common mistake.
Llama.
-4, -5, -6. Am I getting larger or smaller?
Oh, you're getting smaller.
I am getting smaller. So x plus 2 and -3 was the border here. Are we getting less than or greater than this?
Less than.
Less than. -4, -5, -6. So notice, x plus 2 is the circled thing. The circled thing can result in numbers greater than 3. The circled thing can result in numbers less than -3. Questions?
So we're bifurcating this too as well.
Correct. This is a bifurcation, right? Bifurcation, can you define in your own words?
Splitting it up
Split
into
into two statements to solve both, or the way mathematicians break up with their girlfriends. That's what they write them. That's like their Facebook status.
And boyfriend.
I bifurcated with my boyfriend or something. You know? Yeah, just play that on what you said. Thank you, Cornelius.
Yes.
Yes, is how you say you're welcome. Yes, that's what Cornelius say. You guys understand me? Okay, so now let's solve. -2. I maybe shouldn't stomp.
Aren't there people?
There are.
Yeah.
Yeah. There are people below. X greater than 1. -2. -2. X less than -5. Now, can there be numbers greater than 1 and simultaneously less than -5?
No.
No. So is this and or?
This is or.
Right, it's or. Okay.
Oh, so you decide.
And now I'm going to give you a trick. Now I'm going to give you a trick.
Yeah.
Hold the
Question.
question, please.
Okay, why is the sign reversed? The greater than
Because
equal sign.
because what she said in the back was these numbers can be positive or negative.
Oh yeah, and then
We said -4, -5, -6. Because all those will become big.
yeah.
No, that's
So-
But -4, -5, -6 is less than. Right? Now I'm going to give you a trick. All right? Here's an awesome trick. You guys are going to love this.
Yes.
Highlight of the lesson.
I already love it.
Well, you're the highlight of the lesson.
Thank you.
Thought it was me.
What sign is this? Nice. What sign is this?
Greater than.
Greater than, right? I'm going to give you a trick. You see greater? We're changing greater to gray
Or.
tor. Oh! If you
Less
see-
than the.
Yes, there you go.
If you see greater than it's
If you see absolute value, notice we're talking about absolute value. If you see absolute value,
This is
And
so
greater. yeah,
Remember when you bifurcate it?
you bifurcate, it turns to or.
Oh!
Gray tor. Gray
Is
tor.
that always the case when it's a greater?
Yes.
Oh.
Yes, it's
You
always
can
the case.
bifurcate a less than though.
Less.
We will.
I
With
get
the only caveat being, you guys, that the absolute value needs to be on the left. Cool?
Oh, you said the absolute
Variables,
value is on the left,
yeah.
and it's greater, so it's always going to be an or problem.
Bravo. Yes. Okay.
Opa.
Yeah.
So, let's graph this on a numerical lineage.
Wait, it's the absolute values on the left.
Absolute value on the left, and it's greater,
Yeah.
it's or. And this is what I want you to write, gray tor. And capitalize the or. So we have a 1, and we have a -5. And we have a open circle or closed?
Open.
Open, left or right?
Right.
Right. -5, open or closed?
You already
Open.
Left or right?
Left.
That's scary.
I know, I scared myself. I'm like, oh, it's just me. Okay. So, we good? So all numbers, and now what we can do is we can check. We can check this. Give me a number that's over here.
2.
2.
2.
11.
Okay.
3.
400.
How about 10?
7.5.
406. Let's try 10 or something. If we put 10 in here, do it. 10 plus 2 is
12.
Absolute value of 12 is
12.
12.
12, which is?
Greater than 3.
Cool, so all
Yay.
these are good. Now let's try smallies.
Negative 10.
Negative 10. Cool. Good distinction. Negative 10 plus 2 is
Negative 8.
Negative 8.
negative 8. Absolute value of negative 8
8.
is 8. And 8 is also
Greater than 3.
greater than 3. Any questions?
No.
Moving on.
Wait,
Wait, Mrs.
What did Mrs. Spot? Okay.
I know, it's going to be extra fast. Okay. Next one, right? You see it in front of you? 2x, what's it say? Minus 9?
Minus 9, close the line.
Less
Greater than or
than?
equal to.
Less?
Less than or equal to
27.
27.
Okay. Now, let's do the bifurcation. Okay. First statement. Stuff inside, right? Circled stuff can result in what? Guys in the back, stay with us, all right? You're doing great, keep it up. So we have 2x minus 9 can result in what types of numbers? Anything that's...
Positive or negative.
I know, but what types of positives? Anything that's what?
Less than or equal to 27.
Right, less than or equal to 27. And then we have 2x minus 9.
Greater than.
And then, do you recall from last time, something happens to
Don't we
this,
change it?
and something happens to
Yes.
this.
So greater than or equal to negative
Greater than or equal
27.
to
Negative.
negative 27. Okay, is this in the frame there, Mr. Smith?
Yes.
Barely, okay.
Mr.
This guy.
Mr.
So,
something.
here's another thing. Remember you wrote before? Less, oops, you wrote greater.
Less
This is
than.
less than,
Then.
oh, capitalization. Less than, duh.
Such a genius.
Yeah, you called that one. Good job,
Mr.
Mr. Smith.
Smith is a genius.
No,
Hey.
he read my mind.
Okay. And so I'm putting and here, as you said. And now
Solve.
we solve.
That's really clever.
Plus 9.
I know, thank you.
Did you come up with that?
Yeah.
Wow.
But I think that other people use it too.
That's really clever.
Yeah, I've heard it before.
Yeah,
I heard it in algebra and like college.
right on. It's non-proprietary. So then we have plus 9. What's negative 27 plus 9?
It's isn't it 18? No.
Negative 27. Go ahead, yes?
Just to clarify, when
Please.
we are bifurcating
Yeah,
and we make one of the numbers negative,
yeah,
we switch the sign.
yes. Good, I was getting to that. I'll put it in right here. This changes. And this changes. Both the sign and both the direction and the sign of the second statement, okay?
Yes.
But does the left side change?
No.
Okay, good job, Cloverleaf. So now we have x, because you're lucky, okay,
Thank you.
is greater than or equal to negative 9. You're welcome. All right, so this is an and. We have not graphed an and yet, so let's go ahead and put this on the numerical line. 0,
Sorry.
negative 9, 18.
Wait, but what's this?
Now, think of whether,
What does it say?
shh, guys, not right now. Okay. Think of numbers that are less than 18. Which way are we going, left or right?
We are going left.
Left. And then greater than or equal to 9, we're going right. And remember the definition of and. Does one of them need to be true or both of them?
Both.
Both. So what are the only numbers that are left of here and, like you said, right of here?
Negative 8, negative 7, negative 6.
So everything between?
Yes.
Everything between it.
Oh, I remember this stuff.
Yeah! Open or closed?
Close.
Close.
Closed.
I
Both
want.
of them.
Both of them. And then everything here.
Oh, that's how we graph.
Okay? So and implies the overlap. And implies when this is true, all the numbers less than 18. And when this is true, all the numbers greater than or equal to -9. Okay, questions on that one? Okay, I think we have one more. Whoa, I'm getting a call for Yay Math right now.
Wait, seriously?
It's so
Answer.
funny.
Wait, that's your
We might-
Yay
we might
math
cut it
line?
out. Hello, this is Robert. Might want to put on speaker.
I was waiting for an answering machine.
No, there's no answering machine. I'm actually in the middle of filming right now. Who are you?
Oh my gosh, I gave that, it's a long story here. Is there a better time to call you?
Yeah, there is. But first, identify yourself. You're famous now.
Oh, Steve Shapiro is my name.
Yeah.
I just wrote you an email.
Cool.
And picked up the phone to call you to say I'm wonderful, I'm a math teacher, blah, blah, blah. I could go on for hours here.
Wow, it's really nice to hear that you're a math teacher and you're calling. Where are you located?
Colorado Springs.
Colorado Springs. Cool.
That's
Okay. Why don't you? Did you leave your number on the email?
I'm sorry?
Did you leave your number on email?
Yes, I left my
Okay.
phone number and an interesting, yeah.
Okay, I'll call you back.
Email mentioned.
I'll call you back then.
All right.
All right. Thank you for calling.
Thanks.
Peace.
Bye.
Bye. Oh, cool, right?
Are you gonna keep him in?
Yeah, keep it in.
I'll keep it in. Why not?
That's good for the.
He'll be so happy.
We got one more then.
Send him an email.
You'll make his year.
That was really cool.
Wait, look at 2 lines, kind of.
Now everyone's gonna call.
Is it a special Yay math line?
No, it's a
Yes,
cell phone.
especially math line.
Oh, really?
Are
Yeah.
you serious?
Yeah.
That's so
1-888 Yay Math.
Wait,
So
are
it
you
comes up
serious?
on your phone as Yay math.
Everyone call. I'm calling
You
you.
should add.
Everyone's gonna call me now.
Can we call right now?
888.
Please don't. We're still in the middle of something.
Wait, but is it
All
on
right.
there? Other?
You
it's
can,
on the
but like
same
it's
phone?
not Yay math.
I direct it to this phone, yeah.
Cool.
Yeah.
So how do you know it's for Yay Math?
should
Does
advertise
it say?
on
Yeah, it says Yay Math. It's because it's saved as that. Okay, so let's go ahead and solve this one. What should we do on both sides first?
Subtract 10.
Subtract 10. And now we have 5x absolute value is less than what?
-7.
-7. Any questions so far about this?
No.
Okay, now, we're thinking less than, right?
Yes.
Thinking less than. We're thinking of bifurcate.
Yeah.
Now I pose the question to you. What if I said we didn't have to do any of that for this
What?
problem?
Because
Hold the thought, think of it for a sec. I may come back to you. I want other people to think of it too, so hold the thought, I'm coming back to you. What if I said, as the toilet flushes behind me repeatedly, why would I not need to do anything on this particular problem? Okay, I'm actually gonna move on. Yeah, go ahead.
No solution?
Correct.
wait.
Were you gonna say that too?
Yeah.
And you.
Oh.
Good job, Peach. So,
Am I
why?
Peach?
Why, you are,
Okay.
yes, yes. Mango. Why,
I love mango.
why is this no solution correct? Good job.
Because there's a negative number.
And what do we know about absolute value?
They are always positive.
Absolute value is always positive, so the question is, how can something always positive be
Less than.
less than a negative number? And can something positive ever be less than something negative? No.
Oh.
So in other words, will any number work here?
No.
Let's think of any number in the world, like -100, right?
Yeah.
Plug in -100 here.
-500.
-500.
500.
Absolute value of -500. 500 is
So-
not
So
less than that. So question here, please.
Okay, so let's say we flip the sign.
Yep.
It's still starting with a negative,
Yep.
so it's still suggesting that the absolute value could still be between -6 and up.
But it will always be. It will
But
always
would
be
that
that.
Yeah.
would that be also like
No solution?
no solution?
no.
You're in the neighborhood,
No.
but no.
How is it no solution?
This is not no
It's-
solution.
Because
So
if you
what is
put
it?
Good question. That's what we're ending on. What is it?
Wait, what do you
What
mean?
is this?
Can it be just any number? Like if I plug a 1 into the x, it'll be 5 is greater than -7.
Yes.
I can do that with any number.
Correct.
So infinite solutions.
Whoa.
Right, good. I wanted your train of thought to be going on
Okay,
there.
what is that?
What?
This is the symbol, I'm glad you're clarifying, this is the symbol for all real numbers. And let's discuss why.
How'd you
Wait,
make
wait,
that
so-
symbol?
No, it's a known symbol just as much
No, I
as
said
this.
how did you make?
Oh, it's an R with 2 lines.
Like the paragraph sign.
Sort of like the paragraph sign. Okay, let's explain, let's build on
Wait, so if
what
we-
Cornelius said. Yeah,
And that's I'm
Cornelius.
Octavius.
Octavius. Okay, go ahead.
Other class.
So if there's a less than and then a negative on the other side, it's
No
no
solution.
solution. If it's greater than with a negative on the other side, it's all real.
And let's inspect y, again, as the last thing. Notice again, circling this. Everything inside this red box will always result in what kind of number?
Positive one.
Positive, anything, right? Are we clear about that?
Yeah.
This will always be positive. So won't it make sense that if this is always positive, that no matter what, it will be greater than something negative?
Yeah.
Meaning any number would work in there. So that's why this is all real numbers. And those are the 4 situations that we've covered. We've covered or that goes like this. We've covered and that goes like this. So we did overlap. That was the last problem. Right? This is no solution. This would be and that goes like this if you graphed it. And this would be all real numbers or that goes like this. Okay? I'm going to put a quick graph up here. Let's say it was an OR problem. Let's say this was an OR problem. So basically, the solution is this all these numbers or all the red numbers. This is also all real numbers. This is all real numbers. And the reason why is you're looking to satisfy anything that's under this black line or anything that's under this red line. I know it's a lot. It's just I took it to the brink and then we all pushed over the cliff. All right. If you see an OR that's like this, if this is an OR, then this is all real numbers. So you know what? I think it's worthwhile. The responsible thing to do is to go like this. Please draw 3 more lines. We're not going to do problems, we're just going to do scenarios.
Well, we have 2 more problems on our sheet.
I know, we're going to stop at this.
Wait, isn't and wrong? The second and.
I want to, yes, we're going to talk about it now. Okay, and then this is the OR. I'm going to redraw this. It's going to be the same thing. I'm just going to redraw it so that we're all looking at the same stuff. Let's do blue. On the red. So let's do red here. Okay, let's go through one at a time. And I'm going to ask you, do I need to write anything additional here or shade anything additional here? If you have a solution that's OR that goes like this, meaning, you're right, meaning these numbers or these numbers,
No.
right? So this is the solution. So we leave this alone. Now, do I need to write anything additional here in which we're looking for numbers that are, bless you, that are these less than this and simultaneously greater than this?
There's no solution. So.
Yeah.
There is no solution. It's impossible, bless you, bless you. It's impossible to say that numbers can be both less than some number here and simultaneously less than this, or greater than this. Because and both of them needs to be true, which means overlap needs to be true. Overlap, that's what I mean by overlap. Okay. Is there a case where we could have overlap here? There is overlap. So do I need to write anything or shade anything here?
Don't we like just keep the part that's overlapping?
Don't
Yeah.
you shade in the overlap?
Yes, you do shade the overlap. If I graphed an AND graph that resulted like this would be the solution. I could even erase these or cross them out, whatever. So this would be an and graph because it's possible for and to overlap, and you'd shade that
Wait, is
part.
there a reason why you didn't go underneath?
No reason. No reason. And then finally, this is the one we talked about before. Isn't it true to say that every single number under the sun will either fit this green line or will fit the red line or fit both?
Yeah.
Yes.
Okay? Any questions about that? Please feel free. I hope I'm not losing you.
That's everything?
That's everything. So this would be all real numbers. If you had to graph something that overlapped and was an OR graph, you would know that this is all real numbers. Because every number is either green or red or both.
Oh.
So this would be all real numbers. What's the symbol for all real numbers? Cloverfield, peach,
R.
mango, Cornelius,
The R,
Ecclesiastes?
two lines.
Yeah,
R.
R with two lines. You guys, big round of applause for yourselves. That was really great. That was good. And what's my name? I want a name.
Mr. Limpin.
Mr. Limpin. What's up? I gotta be like this. What's up? Mathema Limpin has a hand high up. This is how I teach too. So now we're gonna be doing absolute value, baby. What's up, baby? Pass me your shades.
Oh, yeah.
Oh, they're in the bag. Never mind. Okay, so say bye, everyone. You could hit stop. Bye. Bye.